Assalamualaikum warahmatullahi wabarakatuh. My name is AFIQ bin Ibrahim and my matric number is 229797. So today I will be doing assignment 1, setup x86 programming environment given by Dr. Khairul Nizam. So first thing first is we have to download the SASM and we have to create a new project. And after that, we have to load the average for file. I already download the average for file. So this is the average for file. And first thing first is we need to do is click build and build this. As you can see, the build is successful. And then we need to click the debug. And this is the debugging interface. So first thing first is we need to add this two variable, which is, as you can see, first one is the data and the second one is the result. So let's add the variable first. So first one is the data, and then here you click hex, and then this is word, and the array size is 4. And next is for the result variable, and also this is hex and word, the array size is 1. Okay, so we have already create the memory, and next is this is the register part. So let's start with the debugging first. So in this line 6, you can see this is for the correct debugging, but the debugging process started at line 7, so we need to click this step over. So in this line 7, we clear the EAX by subtracting it from itself. As you can see, the EAX is now 000 when I click step over. As you can see, it becoming 0. This sets the 0 flag. Okay, this set the 0 flag since the result is 0, and also set the parity flag because the low byte has even parity. The interrupt flag remains set, meaning interrupt are enabled. And next for the line 8, we load 4 into ECX, and after I click the step over to execute the line, the ECX is now 4. This is our loop counter for 4 numbers. And next is for the line number 9. In this line, the ESI is set to 8. So same thing, we need to click the step over to execute the line. And then as you can see, the ESI now is set to 8. This offset point just past the end of the data array. And next, we started the loop. So in this line 12, as you can see, line 12 and line 13, we decrement SI by 1. We decrement ESI twice, moving back 2 bytes to align with the next word. So after I click this step over, I will execute this line. As you can see, the ESI becomes 7. Then I click again, the ESI becomes 6. And next is for the 14 line. The line 14, this line, we add the word add data plus ESI into AX. On this first iteration, that's 0, 400. Okay, wait, let me click the step over first. It becoming 0x400, 0x4000. The low bytes is 00, so the parity flag remains set. No overflow or carry occurs. And this is the loop. This loop decrement ECX to 3. So meaning that this loop will be looping according to the ECX. So if the ECX is 4, it will keep looping until the ECX becomes 0. So let's do the loop. As you can see, the ECX become 3. So the second iteration, the ESI decrement to, as you can see, wait, let me finish the second iteration first. So as you can see, the ECI decrement to 4, then to 002. AX at 3000 changing to 7000. And then we do the third iteration. As you can see, the EAX becoming 9000. And then we do the fourth iteration to make the ECX 0. And as you can see, the EAX become 0XA 000. And then we click step over. As you can see, ECX is now 0, so the loop is finished. Okay, next is for the line 18. In this line 18, we clear EDX. So I need to click step over to execute the line. And as you can see, the EDX now is 0. The low byte, sorry, the EDX is now 0. And this sets the 0 flag again. As you can see, this is 0 flag. So for the next line, move CX 04. So in this line, we load 4 into CX. CX shows 04 after I click this. Okay. CX show 4. Okay, the low byte is 04, which has odd parity. So the parity flag is cleared here, as you can see. And next is for the DIVCX, which is the line 20. In this line 20, we divide DX over AX by CX, with AX at A000 and DX at 000, as you can see. This is A000, and DX is at 0. And AX will become, let me execute first, 0x2800, and dx will become 0. The low byte of AX is 00, so the parity flag is set again, as you can see. Next is the print hex. Wait, let me. Before that, this is for the line 21. For the line 21, this line actually store the result. We store the result in the result variable. We store the AX result in this result variable, as you can see in the memory. Because the result will show 2800. And next is for the print hex 2, which is the line 22. So in this line, we print the result. After storing the average into memory, we call this print hex to display the result. This print 2 byte value at result, which should show 2800 in hex. Then we move on to exit the system call, which is the line 23. As you can see, this is the output 2800. And next is for the move EAX to 01. So we set EAX to 1 for the exit system call. Let me execute the line first. As you can see, the EAX become 1. The low byte is 01, which has odd parity. So the parity flag is cleared. The interrupt execute, ending the program. Then, as you can see, right now the debugging process is finished. So we need to click the step over again. And the debugging process is already finished.